Welcome to Alchemical Science. I'm Jordan Collin, an independent researcher and alchemist, and a student of the inventor and vortex fusion specialist Malcolm Bendall. This is the very first part in an important series of lectures, interviews, and announcements that we'll be publishing on Alchemical Science over the following weeks. There's going to be a lot packed into this series. Throughout the series of videos, we will be discussing some significant steps forward in scientists' attempts to understand and explain waterborne plasmoids and their role in the transmutation or atomic reconstruction process that is occurring in the Thunderstorm generator. And we also take a first look at Malcolm's historical alpha and omega ladder diagram, which details the stepwise process of elemental fusion and the accompanying theory presented by Dr. Robert Haralick, who Malcolm's been working closely with over the last several years. My guests also drop a number of big hints and updates on the progress of the mass production and commercialization of the Thunderstorm generator, the Indian float, the involvement and interest from government, military, and academic institutions. And so if you watch through the entire series of videos over the next couple weeks, you will have a good idea of where the Thunderstorm generator and the science surrounding it are at right now. In this first part of the series, we will hear from Dr. Robert Haralick, whom I've already mentioned. He gives what I believe is easily one of the most brilliant and concise explanations of how the Thunderstorm generator and the associated stepwise transmutation process works to date. And before we hear Robert, though, I have another exciting announcement. Roland Perry, a best-selling Australian writer and the author of The Shaman, he has a new book coming out at the end of September, which is profoundly connected to all that we're about to discuss in this series. It's titled Oliphant, a name which you may or may have not heard of before. Although Robert J. Oppenheimer is known as the father of the atomic bomb, the Australian physicist Sir Mark Oliphant was the man who discovered how it could be built. This new book will perhaps give the first real insight into the life and works of a man who influenced science far more than perhaps most people are aware of, and he laid some of the core foundations on which we now stand. So you can pre-order a copy of Roland Perry's Oliphant now on Amazon or from a number of local retailers worldwide. So follow the link in the description for that, or simply Google the title and the author to find it. There's a lot of retailers selling this. Okay, and finally, remember to check the links in the description. There are tons of resources available online. The strikefoundation.earth website contains all of Malcolm's lectures and notes, and you can find the alpha and omega ladder diagram published on there and free to download or print yourself. Robert Haralick's website is also linked to below, and you can find out much more about his work there. Alpha Prospects, the commercial licensee for the Thunderstorm generator in multiple nations, they publish updates on their website and in their newspaper regularly. So I will, of course, be covering the upcoming public float, mass production, and the other important developments in the commercialization as well as the science. And as I say, some of the guests interviewed in this series will shed some more light on what's happening in those areas too. But if you're looking to stay up to date and hear the official announcement from the horse's mouth, you can follow the link to Alpha Prospects website in the description and sign up to their newsletter. And with all of that dealt with, it is my great pleasure to introduce Dr. Robert Haralick, a scientist whom I deeply respect and admire, in this first part of the Alpha and Omega Ladder video series. Robert gave this lecture in a side venue during this year's Tesla Tech Extraordinary Energy Conference, held this month in Albuquerque in the USA, and I was provided this footage and given permission to use it by Strike Foundation. So you can purchase a video on demand recording of the main lecture, different to this one, that Robert gave on the stage at Tesla Tech 2025 on howtube.com, and I've provided a link for this also in the description. I highly recommend you go and watch it. You'll also find some really other great scientists on there, including Bob Greenyer, Moray King, Paul Harris. There's plenty of great stuff. Go and check that out. All right, so Dr. Robert Haralick. He is a distinguished professor emeritus in the PhD program in computer science at the Graduate Center, City of New York. Professor Haralick is responsible for developing the grayscale coherence texture analysis technique and the facet model technique for image processing. In high-level computer vision, he has worked out robust methods for photo and developed fast algorithms for solving a consistent labeling problem. He's also developed shape analysis and extraction techniques using mathematical morphology, the morphological sampling theorem, and fast recursive morphology algorithms. In the area of document image understanding, Professor Haralick has developed a comprehensive ground truth set of some 1,600 document image pages, most in English and some 200 pages in Japanese. He's also developed algorithms for document image skew, angle estimation, zone delineation, word and text, line bounding, box delineation, He has worked in the area of computer vision performance, characterization, and covariance propagation. In the area of medical image processing, Professor Haralick has worked with the left ventricle boundary delineation in X-ray, ventriculograms, and 3D. Professor Haralick is a fellow of the IEEE for his contributions in computer vision and image processing, and a fellow of the IAPR for his contributions in pattern recognition, image processing, and for service to the IAPR. He's published over 650 papers, and he served as the president of the International Association of Pattern Recognition, the IAPR. His publication record can be found on Google Scholar, which by their own count has received over 85,000 citations to his papers in scientific literature. The citations are, even this year, increasing over 2,000 citations a year. At the end of 2021, Professor Haralick retired from the City University of New York after 52 years of being on university faculties. In about 40 of those years, he was as distinguished professors. He retired to set up his own laboratory for research on the new emerging science of water, and he wants to do experiments to show that a person's conscious intention can change the water, and change in the water can be detected by sensitive instruments in his laboratory. And here he is, Robert Haralick. That's quite an introduction, and he is quite a scientist. I think you're going to find this very interesting. Thanks, Robert.
Today we're going to talk about water. But it's not the water that we learned about when we went to school. That picture of a water was where water was, the molecules are floating around, sometimes even bumping into each other, and there was no coherence. And I'll explain the term coherence a little bit later. And it turns out that's not the model of the water. What is the model water is, we'll start from this picture here, and I'll explain it completely. The idea of the water molecules floating around with only electrostatic interactions. That's the model of incoherent water. Water is two-phase liquid. Part of the volume of the water is the incoherent side, and part of the model of the water is the coherent side. This picture portrays, like a little comic book sketch, if you will, a little section of water. Now, there are a number of different colors. You have the dark blue, you have the light blue. The dark blue color is the core of a coherence domain. Around it is a gray with red dots. The gray is called the frontier of the coherence domain, and it's part of the coherence domain. In room temperature, the size of this is around 70 nanometers. And it includes something like 5-6 million molecules of water. The dark blue is the core, and the gray is the annulus of the coherence domain. Let me go to the others, and then I'll explain the coherence domain a little deeper. The light blue are little volumes that are growing bigger and are becoming coherence domains. You'll see that it has no annulus. The white, the background, the white, that's incoherent water. And the green dots are ions in the incoherent water. And the ions in incoherent water obey exactly electrostatic kind of interactions. Brownian motion, things bumping into each other, and so on. And now, if we take this water, which is sitting in an ordinary place, like in a glass. And we have the Earth's magnetic field that's coming through. That's a static DC field. And that strength of the DC field, now it depends upon where you are, typically what latitude you're located at. So that's a DC field. And for this picture, to finish my explanation, I'm supposing that we have an AC current that's flowing, let's say, from left to right. And let's suppose the right side, DC, is the positive. Left side, what am I saying? My left side, when I look at that, you're the right side when you look at the image. That's where the positive anode is. The cathode, the negative one, is on this side. So the electric field is, the electrons would be moving naturally from the left to the right. These red dots are the ions. And if the AC field is at the right frequency, which is called the ion cyclotron resonance frequency, what happens with the gradient electric field this way is that an ion from here will, which is sort of going around like this, will jump to this guy, go around, and then jump to this guy to go around on its journey to the positive electrode. The difference is that this journey through here, through here, through here, and so on, that journey is without friction. That journey is a journey with laminar flow. Coherent laminar flow. And so when if you were to do a frequency sweep on the AC field from very low frequency, we're typically in the audio range here, say 1 hertz, and bring it up to like 50 hertz or 60 hertz. When we come to the ion cyclotron resonance of the frequency, which depends upon the mass of the ions and the DC field, we get this laminar flow that's flowing along. What's important is that there's a resonance effect. And this is what I'm going to explain. They're called coherence domains. A coherence domain in water is a collection of around 5 million or more water molecules in some kind of a compact volume, and they're all oscillating in phase within a self-entrapped magnetic field. What is self-entrapped magnetic field? In the core of the coherence domain and its annulus, there is an electromagnetic field. And that field is one which is not radiated outside the coherence domain. It's trapped within. And we're going to see a resonance between what's going on in the ions, even what's going on outside the coherence domain, and what's going on inside the coherence domain, and what's happening with the field. To begin to explain this, we're going to have to look at a particular electron, just to keep everything very simple. And the electron we're looking at is the electron of a hydrogen atom, and which is a part of the element, the 2 hydrogens that link on to the oxygen of water. The electron, as we were taught in school, which was based on whatever we were taught at that time, was based on the Bohr model of the atom. You know, you have electrons that are orbiting in some kind of circular fashion around the nucleus. Nucleus has the proton and the neutrons, and everything is particles. Actually, it's a good picture, but it's not the reality. The reality is more is that we have waveforms. The waveforms are harder to visualize, and there's an exact translation between the particle and the waveform. So I will just use the knowledge, the concept of the particle. The orbit of the electron that's closest to the nucleus is named the 1s orbit. So that electron, if it goes to a different orbit, the energy changes. The next orbit is called 2s, and that orbit has an increase of around 10 electron volts to go from one to the other. And as you go to the outer orbits, the electron volt increases, the energy increases. Where does it get the energy to go from the inner orbit to the next orbit? This comes from 0-point energy. It's the energy of the vacuum. What's happening in the vacuum is not a vacuum. Right? The vacuum, there's nothing there. There's a lot there. And so just continuing with our particle, a particle and its antiparticle sort of pop into existence. It doesn't stay very long, very short time. But when it comes into existence, it's oscillating because it's carrying energy. If the frequency of that energy is such that that energy is just the amount of energy that the electron needs to move from the inner orbit to the next orbit, from the 1s orbit to the 2s orbit, the electron by resonance picks up that energy and it essentially has moved to the next orbit. And this is a ratchet effect, orbit by orbit by orbit, until it reaches the outer orbit, which is the 5D orbit. And that orbit has an energy of 12 electron volts. All right, if I have to relate that back into the quantum idea, actually what's going on is that there's a superposition of states. Here I'll just show the equation on the bottom is the superposition. Probability P is the probability that it's in the 1s state. Probability 1 minus P, if there's no other things to consider, which is the second state, the 2s state, that's the probability for the 2s state. And the superposition is written like this with the square roots. You don't know where the electron is at this point. That's the description of what's going on. The electron is simultaneously in the 1s state and in the 2s state. And if you ask what is the probability that it's there, you'll know the probability by making the measurement, but before that you won't know. Superposition is a very important concept. You don't know until you make the measurement, and this is the probability that the measurement will say 1s orbit, or the measurement will say 2s orbit. I think I said everything here. So the electrons exist in the superposition of energy states. There's a fixed phase relation between them, and the electrons are oscillating between these energy states in phase. Because what I haven't told you yet is that as the electrons go orbit to orbit to orbit, and they're now get to the outer orbit, they then begin this oscillation from the outer orbit to the inner orbit to the outer orbit. But you have these millions of water molecules, and this one makes the jump finally to the outer orbit at this point in time. Another one is coming at another point in time. So this one is at the outer orbit, this one is at the inner orbit, and they're oscillating. But there's not a phase. This one is in a random phase with respect to this one. So they're all oscillating together. Same frequency, but incoherently. But they're all related because they're water molecules next to each other. And if I have a pendulum, 10, 50 pendulums, all of the same design, and I start them on a table, start this one, then this one, then this one. So now they're all going in their own up and down oscillation like a pendulum. They're completely incoherent with one another. Then what happens? Because I put the pendulum on the table, there is a mechanical connection of a tiny, tiny, tiny amount of energy from one pendulum to the next. And you see, the pendulums love one another. And they gradually, over time, and start swinging like this. Or relative to that electron, they're now moving like this, up and down, up and down. All synchronized. The coherence domain gives water a different set of properties than in the incoherent water. Because they're all moving in phase, there's laminar flow, which happens with the ions, which I've told you about just earlier. There's no Brownian motion. It's all coherent. And when the electron is going from the lower orbit in this oscillation to the higher orbit, orbit means energy level. When it's at the lower orbit, the electromagnetic field has the high energy. And at the moment that it gets to the high energy, the excited state, the field gives the electron the energy to make the jump. And then when it's at the highest state and it goes to the lower energy state, the electron gives up its energy to the field. This is a resonance. It's an energy resonance phenomenon. When I have two strings with the same tension and same diameter strings, and so when I pluck one, it sounds at some frequency. If I were to pluck the other, it would be the same frequency. But when I pluck one and don't touch the other one starts vibrating. That's resonance. That's an oscillation now that's going from one place to the other. And of course, as it goes this way, it also gets sheared back the other way, at least some of it. If I have a whole set of strings, what's going to happen? I start the one oscillating, and eventually all of them are oscillating. And if I were to check the phases, when this goes up, this one goes up. And this goes down in intensity, the other one goes down. That's coherence. So this summarizes what I said. The electron starts out at 1s. The virtual particle pops into existence. It carries an energy. The energy is an oscillation. And when the energy of the virtual particle matches the energy needed for the electron to jump up, it jumps up. And when it gets to the outer orbit, it's at an energy about 12.07 electron volts. Now think of that process. It starts out in the inner orbit. Its relative energy is 0. It gets to the place where it's oscillating. Not just one from the inner orbit to the outer. They're all going up and down, up and down. The energy that popped in from this particle that popped into existence, it had basically low energy. That is, the probability of a high energy is small and the probability of a low energy is high. And it had high entropy. Entropy is a measure of order. High entropy means disordered. If you give me something that has low energy and it's disordered, I can't use it. In classical physics, that's the state of the universe. It's all running down to where the energy is all high entropy energy and you can't use it for anything. But that's not what happened here. Because the energy that's picking up from the 0 point is now getting these electrons to go in synchronization, in phase. That's ordered energy. And this oscillation is going from this 12 electron volts to 0 relatively electron volts. Back and forth. Relatively, it's high energy, low entropy. The process that does it is a negentropy process. Classical physics would not say much about a negentropy process, except that the energy is coming into this closed system from the outside. Outside. The vacuum. Where's the vacuum? Where's the vacuum in this water? Well, the molecules. What's between one molecule and the other molecule? Its neighbor. These are water molecules. You going to tell me it's water in between? I just said it. They're neighbors. What's in between? It's the vacuum. The vacuum is in between. The vacuum is all around us. Even each of us is mostly vacuum. And you think the vacuum has nothing. But we just said it pops out of existence. I didn't say that it moved from one place to another. It's just when you're looking at it at this moment, it's not there. And another moment, it's there. This is very strange, but this is the quantum world. And we have now an energy source which is able to do work. In fact, this is sort of what's happening with the coherence domains. So let's see. We talked about the resonance. We talked about that the effect is a ratchet action. We talked about how much energy it goes from 1s to 2s to the outer orbit, which is the 5D orbit. It's about 12.07 electron volts. And we talked about it only with a single electron. But this is happening to all of the electrons of all the hydrogen atom and all of the electrons of all the oxygen atoms that are part. So not only is there a resonance between the different water molecules, there's a resonance between the hydrogen atom, what's going on, and in the oxygen atom. It's even higher than that. Because when the hydrogen atom is attached to the oxygen atom, we have these valence electrons that are being shared. And they're oscillating toward and away from the hydrogen atom to the oxygen atom. Actually, there are 6 ways that it oscillates. And all of these oscillations are in sync. It's even higher than that. That part is not well known. It's not been explored. But there's energy that is in oscillation, and there are effects that one thing is influencing another by a resonance that's not carrying any energy. This is a new thing. How is it that certain pair of people, when one person thinks one thing, the other person picks it up? It's called telepathy. Tell me about the energy from the one person that's going to the next person. Really, energy? From California to London? Energy? From India to Alaska? Energy? Tell me how much energy it starts out from. Tell me how the energy is traveling, and then the further away it's traveling, the energy splits out, and the density of the energy gets smaller and smaller and smaller as it goes outward. Really? From India to Alaska? And the energy so minuscule that could be measured from the person. That's not what's happening. It's happening by a flow which is a non-energy flow. Wait a minute. Haven't we been taught that if something influences something else, it influences by an energy exchange? This was a fundamental principle in physics. Classical physics, Newtonian physics. You can't have anything influence anything else unless there's an interaction of energy. And this oscillation that's going on has in it the part that's the energetic part that I spoke about. But there's another part that's not known, it's not being talked about. When the consciousness of one person relates to the consciousness of another, it's a non-energy field. Non-energy fields in physics exist. Not only do they exist, but when the quantum physics people begin to write the equations, quantum physics equations, they start from these non-energy carrying fields. In the case of the magnetic field, they talk about the vector magnetic potential field. Potential means it has no energy. Same thing on the electric side. It's in the quantum equations from the 1980s. The public? The early semesters of physics? Blank out. It's not talked about. But in some sense, this is the way the world works. Now we're going to go and get to the place of the thunderstorm generator. And the thunderstorm generator has these pipes, a pipe within a pipe, a sphere within a sphere within a sphere. And you look at the ratios, 4, 3, 2. 4 to 3, could be 4 inches, 3 inches, 2 inches. Could be 24 inches, 18 inches, 12 inches. They're all the same. They're all the same. How can it be the same? Well, tell me what's going on in music. If I have a song and it's up in this octave, and I have another song down in this octave, is it the same song? Are all the relationships between the tones the same? Absolutely. 4, 3, 2. The diameter of the moon is 2,160 miles. In the Vedic mathematics, you ignore the zero. It's 216. 216, 4, 3, 2, what's that? It's a 2-to-1 ratio. It's in the next octave. Tell me about the sun. The sun is 864,000 miles approximately in diameter. 864, 432. The sun is on the next octave up 432. The moon is an octave down. Now, when I have something going on in the earth, in the physical material environment in the earth, and it's that something is going on in these kind of ratios, there's a signal. It goes back and forth, but the signal doesn't carry you the energy. And so there's a resonance of Malcolm's 432 ratios to the sun and the moon. The ratio idea is not new. Kepler wrote a book called The Harmonies of the World. Kepler wrote how each planet in the solar system, he considered the time it takes to revolve around the sun. He considered the rotation rates. He considered the mass. And what did he figure out? He says everything is in accordance with the Pythagorean tuning. There was an article published in a specialized medical journal that deals with all the glands in the body and the hormones they produce. The study looked at the chemical formula for each of the hormones, the main hormones for each gland, found out the frequency that's the natural frequency for them. And guess what? They all belong to a Pythagorean tuning starting at 1 hertz. Let's take good and bad. What's good is life affirming. What's bad is life detrimental. There was an article published in 2017, authored by, let's say, a quantum physics, Hans Kiesing, a biologist, Igor Duman, and a retired professor of pharmaceuticals, pharmacology, I guess I should say, who teaches that at the graduate level. They surveyed articles from like around 1950 to around 2015. 1960 to 2015. Look how many years it is. It's over a half a century. Tell me what happened to the technology of measuring things in over a half a century. It's like there's no comparison. Nevertheless, they looked at articles that were saying we're frequency treating either in vivo or in vitro, for example, a cancer. And certain frequencies are life detrimental and makes the cancer grow faster. Other frequencies slow down the repetition rate, and therefore they're life affirming. When he gathered all of the information for the life affirming, he found frequencies. All the frequencies are in a Pythagorean tuning starting at 1 hertz for the C. What about the life detrimental frequencies? This is going to blow your mind. The life detrimental frequencies also satisfy a Pythagorean tuning. But where does the tuning start? A half of a semitone shifted. In other words, they're in like this. So if you want to know where the bad is relative to the good, it's intertwined. the Pythagorean tuning. This is different than the kind of tuning we have in the orchestra and the instruments. And by the way, you know where the A is? That's above middle C? 432. And you know where 440 is? It's in the life detrimental mode. Now, I just say this because we're talking about resonances. We're talking about things relating one to the other. And when these relationships are considered, if you're at 19,000 hertz, that's resonant with 1,900 hertz. So it's not so much the difference in octave. It's on what note you are. So we have resonances which are happening not because of the absolute frequency, but because of frequency relationships which are exactly the musical relationships that notes have one to the other. And A is an A, whether it's all the way up in the treble or it's all the way down in the bass. All right, let's move on. I just give two examples for resonance. Example number one, in electronics, there's an LC circuit, conductor-capacitor circuit. An inductor-capacitor circuit has resonance, causes oscillation. That's the tuning mechanism. It's an LC circuit for the radios, for example. Start. The energy is in the capacitor. It's in the electric field of the capacitor. Capacitor begins to discharge. The electrons are moving through the inductor, where the magnetic field is caused because of the current flow. And then it's stored in, all the energy got transferred from the electric field of the capacitor to the magnetic field of the inductor. And then the inductor discharges, and the electrons move out of that field into the electric field of the capacitor, back and forth, back and forth. What happens if I have a spring? I tie it to the ceiling. The spring comes down. At the end of the spring, I put a mass, a weight. I pull the weight down, and the spring moves it up, and it goes down. When it's down, the mass has lost potential energy, and the spring has gained that energy. And then when it goes back up, the potential energy has increased of the mass, and the energy in the spring has decreased. It's exactly an exchange of energy. It's even deeper than that. If I had to write the equations for the mechanical system, and I wrote the equations for the electrical system, the mathematics, second order constant coefficient differential equations. It's exactly the same thing, except one is concerned with capacitance and inductance, and the other is concerned with actually height, which is where the potential energy comes from. The higher you are, the greater your potential energy, and the energy in the spring. The solution of the differential equations are sine waves. And actually, if you were to listen to a musical note as a sine wave, no harmonics, it's kind of a very simple sound. I begin to add harmonics, it begins to take on the character. Sine wave. But when I go from the outer orbit to the inner orbit and back to the outer orbit, there isn't a constant coefficient differential equation. It's nonlinear. And now we're talking about waveforms that are more like square waves, or waves that fall off linearly on their edges. The sound, maybe the square wave is not as pure as the sine wave. And that's the nature of these oscillations we're seeing here. It's from a nonlinear process. So, just like an LC circuit, just like a mass spring system in dynamics, we have oscillations. The equations are exactly the same here. These two, we're in another system. They're nonlinear equations. I think we talked about the multiple oscillators and the pendulums, and how if they're oscillating just at random phases with respect to one another, because of how they're placed next to each other or in some medium where there can be a little bit of transfer of energy, they all wind up in the same phase. Thermal energy. Let's go back to our model. The electrons go from the outer orbit to the inner orbit, the high energy, low energy. How much energy is needed to separate the electron from its nucleus? Think about its proton in the hydrogen atom. 12.6 electron volts. When that electron gains an additional, a little more than a half of a volt, electron volt energy, it's able to separate from its proton. But this doesn't mean it takes off and goes into outer space. It sticks around, close by, but not as close as its orbit would have been. But it has a greater degree of freedom of motion. It's called a quasi-electron. We haven't talked about the shape of the coherence domain. Usually it's depicted as a sort of a spherical shape. Particularly these circles, these are like cutting a plane through a sphere maybe. I've had extensive talks with a quantum physicist, and he's suggesting the shape is a torus. And in fact, in what I'm going to say, that makes a lot of sense. So, our assumption, our hypothesis, is the coherence domains take the shape of a torus. Where is that self-entrapped magnetic field? In the tube of the torus that's going round and round. That's where it is. And all the water molecules there are oscillating in phase. But I said a tube, so right away we visualize a plastic or a metal tube that goes round, like a pipe. But here isn't a pipe. There's no membrane that separates the inside from the outside. But what's going on the inside and what's going on the outside are two different things. And that's the separation. Okay. And I think we talked about the oscillation from the outer field to the inner field and back, and the interaction it has with the electromagnetic field. Now I'm going to go one step further. We said something about potential fields, fields that carry no energy. And in Maxwell's writings, he does talk about the magnetic vector potential field, and he talks about the electric potential field. And if we're thinking about the magnetic field that carries the energy, it's written by the letter B. And its inside the torus, going round and round in the circle, strongest in the center. The magnetic vector potential field is sort of like the coil, if you were to make a coil, but the coil is a winding, but the potential field. So if I'm talking about the section of the torus, which is over here, different layers, but all going in circles around it. And what happens when I have a big circle here, it goes around it like this. Now I'm in the hole of the torus. And a big circle here that goes like this on the other side of the torus. The field on the inside, the vector magnetic potential field increases. The place of the strongest A field is in the hole of the torus. The cause of the energy field is the potential field. Hold a minute. Cause and effect? Field that has no energy is causing a field that's carrying the energy? Again, this is not common sense. But that's the reality. The quantum physics people today, actually starting from approximately in the mid-1980s, are writing all their equations starting with the potential magnetic field and the potential electric field. And the reason why that is the cause and the energy fields are the effect is because there are infinite variations of the potential fields which will cause the same energy fields. So that relation is unique, but the relation back is not. If you just tell me the energy field, I can't tell you what the potential field is. You tell me what the potential field, I can tell you what the energy field is. And so quantum physics starts from the potential fields. And the potential fields are the cause of the energy fields. This is counterintuitive. How is it that something that has no energy is causing something that has energy? Welcome to the quantum world. Actually, the proof of this is actually very simple. It's given on the last line. You see, the B field this is the symbol for partial derivatives, and the cross is an operation in the vector calculus of this world, and this is called the curl of the A field. So if the A field has no curl, which means no circular kind of things going on, the B field is going to be 0. But if it has curl, the B field, the energy carrying field, is something. And what this says over here very simply is, if I take an A field and I add on it to another field, a U field, where that U field has the curl of 0, then by the linearity of the cross operator, it goes just like multiplication and addition go in standard arithmetic. The A plus the U turns out to be del cross L, A plus del cross U, and del cross U is 0, so it's to get del cross A. So if the U field is 0, you get the same del cross A for any field which has no curl. That's the proof. Now, start a visualization. We have a torus. That's the coherence domain. The B field is running around inside like that. The vector magnetic potential field is strongest in the hole of the donut. And if it's going around one way, it's pointing up. If it's going around the other way, it's pointing down. And now what happens when I stack a torus on top of a torus? So I'm not up to that yet. So if I have one torus stacked on top of another torus, each has an A field, a field that has no energy, and it's strongest in magnitude in the whole of the torus. So if I stack one, it has the A field pointing up because it's going around in a clockwise direction, and the one below is a counterclockwise direction in the field pointing down. What happens when these two fields, one is going up, one is going down, and what happens at the place where they're meeting? We get a partial cancellation. And so if we cancel out, meaning reducing the magnitude of the A field, what happens to the B field, the energy carrying field? It's reduced. And now, if I ask about the stability of the physical material formation of these coherence domains, and one of them, they're reinforcing each other, and then the other, they're sort of canceling each other, which is the stable one. The one where you get the reinforcement. So that means if I have a stack of tori, the stable configuration is that magnetic field inside the torus. It's all pointing in the same direction, so let's say clockwise direction or counterclockwise. Next, what happens when I have them stacking left to right? Two conditions. One of them, they're both going around clockwise. And what happens at the place where they meet? This is going around like this. When it gets to here, it's pointing this way. This is going around like this. When it gets to here, it's pointing the other way. Right at the place they meet, they cancel each other out. Therefore, the stable configuration is where one goes clockwise and the other goes counterclockwise. So there's the illustration of the stable structure. They're all in the same direction. And there's the configuration where they're one next to each other in this left-right kind of configuration. And you can see in this here where you're going clockwise in both of the right, we're going counterclockwise in the left, and where they meet in this area here, this section here, they reinforce one another. So this is the summary. The tori have a preferred configuration of forming stacks. They're not floating around in random motion. They tend to make stacks. Each stack, the electromagnetic field is, I say propagating, or I should say that the magnetic field is pointing in the same direction. And for neighboring stacks, that propagation direction of the field has to be opposite, and that provides the strongest state. Now let's talk about the dynamics of what's going on in the torus. Running just outside of the torus are the electrons which have escaped its orbit. So they're electrons with 12.6, 12.7 electron volts. They escape to the other end of the universe. They stay nearby. And they stay, and they're in motion. So in the torus, the motion is around the tube of the torus. But it's not like a winding. A winding you wind around, and that follows the spiral path of the winding. There isn't the widening. The electrons are in a current sheet. And so either they're all going this way into the pole of the donut, or they're going the other way from the hole around as a sheet pointing to the outside of the torus. It's one or the other D spot. And remember I talked about an ionic current? So this is if I'm sweeping frequency from low frequency to high frequency, I get whatever this low value is, which in this case is negative, and then it peaks up, and then it goes down like that. And so that's what happens when I have the ion cyclotron resonance. That's the peak. Now let's go to another area. Chinese medicine. Chinese medicine is all about meridians. And if you go look in the anatomy, and you use your eyes, and you look at where the meridians are supposedly placed, and you look at it very carefully, even with a magnifying glass, you won't find the meridian. That's why you'll see a whole bunch of things that say the meridians don't exist. I can't see it. Hey, take an electron microscope now, and now look. There's a string of proteins right where the meridians are. The proteins are hydrophilic. They love water. And there's a set of coherence domains of water wrapping around the protein. And what's going along on the proteins? There's a signal that's actually carried by ions. They happen to be the ions of a plasmoid. Which itself carries energy, carrying carries ions, carry charge. The proteins are cylindrical with a very, very small diameter. And one cylindrical protein links onto the other, and there's a junction between the two. We're in the world of coherence domains. We're in the world of laminar flow. That junction is exactly the place in the classical physics world where there would be high resistance. Hey, not along the meridians. The reason is because the junction is a Josephson junction, which in the superconducting world is what happens. No resistance. So we have flow that's laminar and easily crosses the junctions between the one protein and the other. Let's go to another world. The plasmoid world. There's a famous drawing. I actually didn't make a picture of it. Circle, a little sort of S-shaped relationship. Yin yang. One is called black, the other is colored white. That's in balance. The coherence domain is not in balance. It doesn't have a yin yang. The plasmoid is a structured plasma, and it does have a balance, and the plasmoids are carrying the ions and on the energy as we're going down or up on the meridians. We'll come a little closer to that later. Here's the formation of the plasmoids, where we have two counter-directional coherence domains and they're right up one against the other. And something is going to happen. What happens is, like in the homeopathic process, you shake very vigorously, and then you dilute. I'm concentrating on the shaking. The shaking causes bubbles. The bubbles, some are large, and the bubbles, some are small. The bubbles have a different process within them. The outside of the bubble is charged negatively. The inside of the bubble is charged positively. The large bubbles, they rise to the surface and they explode. The tiny bubbles on the order of the microscale, they remain small and get smaller and smaller and smaller. They cavitate. So when we shake, the interface between the liquid and the air form bubbles in the liquid. Those bubbles are bubbles from large-scale bubbles to micro bubbles. The large-scale bubbles, they come up and they explode. The small bubbles, the micro-scale bubbles, get smaller and smaller as you disturb them. Tell me what happens to the pressure of the air inside the bubble as the bubble goes from this side to this size to a tiny, tiny little thing like a point on a pencil. Pressure increases. And what happens when the bubble pops? The positive charges from the inside link to the positive charges on the outside. And what happens when the positive charges and negative charges meet? Typically, you would get a spark. You would know that they met by a spark. But these are so tiny little things, you may not see the spark. Although certain conditions, you would be able to see it. Particularly in the ultraviolet region, light, that our eyes are not sensitive to. So we have a discharge when the bubble cavitates. And that forms the picture I want to portray is rays of electric field energy going from the point at which where the bubble has cavitated, go outward to all these different directions, like a sphere full of needles going all outward. Yes, another bubble picture. Now I think I said this. And now let's go back to our relationship of two tori. One of the fields, magnetic field, is pointing clockwise, the other one is pointing counterclockwise, and that yellow arrow, that's a ray of a longitudinal electric field ray, and it happens to come exactly between where the two tori meet. That causes a fusion of the tori together. One of these directions is expansive. The other of these directions is contractive. That's your yin and yang. And where the fusion happens is an area that now takes on a property that's in certain ways similar to a black hole. It's called the 0 point. And the 0 point has special properties. So when we shake the remedy and make these bubbles, and the bubbles collapse, the small ones, and cavitate, and cause this ray of an electric field longitudinal electric field, and they come right in between. They do the fusion, and the fusion causes a class B. The plasmoid is balanced because it has the yin and it has the yang. And the place where the two come together is the place of this 0 point. Things that are balanced have different properties from things that are not balanced. And what we're going to talk about now, we'll get into, is what's going on in the thunderstorm generator. So I think we've said this. So here's our picture. Hand drawn. Two tori. You see they're going around in different directions, the fields. You see the A field, one going up and the other going down. Tell me what happens right in between these two lines. This one's going up, this one is going down. When they meet in the middle, 0 A field, they cancel each other out. If there's 0 A field, tell me about the magnetic, the energy carrying magnetic field. That's equal to the curl of the A field. And if the A field is 0, the curl of the A field is 0. So this is a place where there's no magnetic field. Same time they're here. You see here the electrons, they're moving around. This one is going from the inside to the outside. This one is going from the outside to the inside. That's the sheet of electrons. But what happens when the B field is 0? So the generalization of Maxwell's equations explains that when the B field is 0, the kind of waveform that exists is a longitudinal wave in that area, in that volume. Longitudinal wave means it's going back and forth along the direction of propagation. And when that happens, in that area where there's the B field is 0, there's a scalar field. Now, if you've listened to the, let's say, the new kinds of things that people are talking about, when they talk about scalar fields. Unfortunately, some of the people who talk about scalar fields didn't even know the definition of a scalar field. A scalar field means every point in space in which it exists has a number associated. It's not a vector. The temperature of this room at any point in the room, you put all of those temperatures together and order them. That's a scalar field. So there's a scalar field that exists in this little green elliptical shaped region. It's a field. A field is not just a number. It carries a unit. Temperature carries the unit of temperature. The unit in this field is exactly the same units by which energy magnetic fields have units. The modern unit is the Tesla. The old unit is lepers per meter squared. So we have in here magnetic field, energy, but not as a vector field, which has a direction, just as a scalar field. Different properties. And now we go back to this image. When I was talking about this image before, I didn't talk about the spherical shape. I just said it's like a sketch in a comic book. You know what this is? We're looking at the cross-section of a torus. We just sliced it in perpendicular to the plane of the torus. And this is the core that has no ions. This is the annulus region around the ring that we talked about before. That's what's going on. And now we come to the thunderstorm generator. You can see here, there's an engine. It's mounted in a frame, the engine. And this part of the engine is actually the generator. We'll start from here. Air comes in here, it encounters a ultraviolet lamp. You put water in here, and the water is traveling from the bottom here to the bottom here. And this is at a higher elevation, so the water begins to build up as the water is poured in here. Eventually, the air will be pulled through the water and make bubbles coming up. And this material over here is a lot of stainless steel tiny strips, almost like the kind of thing that you would use nowadays. It's typically plastic to clean a pot. So the bubbles come up from the air here, and they go through here, which chop the bubble in half and chop the bubble in half again and again and again until it gets to a very small size. And then the air comes up through here and into this section of two spheres. If I were talking to an automotive engineer and started to explain, yeah, look, there are two spheres. Actually, this is a sphere within a sphere within a sphere, 3 levels, like the Russian dolls. And this tube over here is a tube within a tube. And the air bubbles come up around here. And what did I say happen when you have bubbles? And when the bubbles cavitate, what happens? You get that little spark of energy. And the water is carrying the coherence domains. And the coherence domains form stacks. They meet each other left, right. And the longitudinal wave fuses together 2 tori of neighboring coherence domains, and that forms the plasmoids. So as we're going up in the bubble, from the bubbler, the plasmoids are coming up. And then they have their part. They're in the part between the central sphere and the inner sphere. And they are rotating around in a clockwise direction. And then they go up, rotate again in this sphere in the same kind of configuration in a clockwise direction, come out, go up and around over here, and go into the carburetor. Here is the exhaust. It comes out into the sphere and goes counterclockwise between the middle sphere and the outer sphere. And in here, something happens. Transmutations. Things that are not in the air. Elements that are not in the air and not in the fuel begin to form in here. Then it goes down here, going the same anti-clockwise direction, and comes out. This is the end of the exhaust. Now, what's very special about this configuration, which everybody looks at, knows all about automobile engines, would say, that's not going to do anything. I think I covered this. When you look at the exhaust, what do you expect to find? You're burning a hydrocarbon. So the oxygen from the air links onto the carbons and form carbon dioxide. And the oxygen of the air links onto the hydrogen from the hydrocarbon and forms water. So we have oxygen tied up in the carbon dioxide, tied up in the water. But what we find when we look at the gases is that it's low carbon, maybe in the 1% area, carbon dioxide. 1% rather than 10%. Low nitrogen oxides, which typically are around 1%, they disappear. Low hydrocarbons, also typically in the 1% area, disappear. And a high oxygen. High oxygen. With a properly constructed arrangement, meaning no leaks. Could be 19–20% oxygen. That's unheard of. I could breathe the exhaust. What happens when somebody tries to breathe the exhaust of an automobile engine? Take your engine, put it next to the window in the bedroom. What's going to happen? The carbon dioxide and the carbon monoxide are going to come in through the window, and the person sleeping in the bed is going to die. And that happens. I don't know what the statistics are, but it's in the tens of thousands of people each year in the United States. So the question is, how does that happen? It's unbelievable. I can't look at that in any mechanical way. I can't look at that in any chemical way to say what's going on. And if you start to think about it, well, if there was high carbon before and there's low carbon now, and there was almost no oxygen before, and now we have some oxygen, you might think that the carbon transmutes to the oxygen. Actually, that's what I thought. Something else is going on. When we take a look at what's inside the spheres on the surfaces, we find there are residues on the surface. What kind of residues? Residues of elements, tied up chemically various ways, which are not present in the fuel or the air. And now we're going to take a look at some of these. I think I've actually said everything here. We're going to take a look at a Caterpillar engine that's tied up with its generator. 400 kVA. The engine had about 500 hours of operation over a few-year period. The engine would turn on when the demand of the electricity on the transmission lines was getting too high, and so it would turn on to give the transmission lines some additional energy. Otherwise, the electricity would have to be cut off. The sphere sizes were 18 inches, 24 inches, 18 inches, and 12 inches. And what ratio is that? 24 to 18 to 12. Divide by 6. 4 to 3 to 2. You see, it didn't make a difference, the absolute size. What only made the difference was the ratios. In 2024, in the area of March of 2024, Malcolm had the spheres disassembled, cut into pieces. Most of the pieces were about 2 inches by 2 inches. These pieces were given to Bob Grenier of the Martin Fleischmann Memorial Project to examine. Grenier talks tomorrow, by the way, here. Malcolm paid for his transportation to get from the European country he was in to scanning electron microscope. I think it was in California, maybe. The analysis of those residues by the scanning electron microscope, which had an energy dispersive spectroscopy system, which means if you mark this is the place I want to look, you place the electron beam there, at a point, at a circle, among a line segment, however you wanted but to do it. The energy dispersive spectroscopy system looks at the scatter of energy from where the electron beam was pointing and tells you the elements present. It could be something with an oxide, could be something with a sulfate. Tells you the presence of the element, not the chemical formula, but the presence of the elements. How much of each. And that system was showing the presence of carbon, oxygen, and nitrogen. Good, that's clear. Silicon? Sulfur? Or maybe you can say that this was a gas-driven thing, a natural gas. Maybe you say some of the sulfur came from a natural gas. Fine. Calcium. Sodium. Aluminum? Really? Chlorine? Zinc? Magnesium? Titanium? Chromium? Iron? Well, the iron, you can say it's stainless steel. It's coming from the steel. Nickel? And there are others yet. That's a difficulty. Elements that were not present in the air and the fuel show up in the residue. How is that possible? It's not a chemical reaction. It's a transmutation. Here's a little bit of the proof. We have 50, 60 images of this kind. This shows a 29 micron field view. From the left side to the right side is 29 microns. A micron is a millionth of a meter. And you see, carbon, nitrogen, oxygen, yes, aluminum, sulfur, chromium, iron, and nickel here. And to these concentrations. High concentrations of oxygen, which means we have an oxidation going on. But these other elements, aluminum, chromium, nickel, what about them? That's one. Here's another. This is an example of a crenulated sphere. The top of the sphere has broken off, and what remains is this piece here. And so we have something form on the outside and something is on the inside. In this case, we're looking at the top, right here, this region. Yes, carbon, nitrogen, oxygen, you see that all the time. Aluminum, silicon, sulfur, calcium, chromium, iron, and the outlier is promethium. And the last one I'll show is this one here. This one is interesting. Start off from here. You see, it's a tubular kind of thing, and then it has a bulb of something here. The tubular kind of thing is a little bit translucent. To another one, 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 and then here. What's going on here? It's a string of pearls with carbon. And they're spaced that way because there must have been a standing wave. And that carbon is not ordinary carbon. That carbon is diamond. We're going to try to make a hypothesis of how it's possible for these observations to have taken place. To be simple, we will assume an ideal complete burn. That means there's no carbon monoxides. There are no nitrogen oxides. The input to the engine is fuel, air, which is composed of nitrogen, oxygen. The next one after oxygen, I believe, is something, a small amount, around 1% of argon. And the air is carrying humidity. It's carrying water. Most humidities are 50% or higher. Unless you're in this region here, which is a desert. And then you get lower. What's going on with the spheres is where we have a coherent resonant energy with the plasmoids. They disassociate the CO2 into carbon and oxygen and the H2O of hydrogen and oxygen. The CO2 is more of a complete disassociation. The H2O is partial. The hydrogens fuse to make helium. Some carbons are put into a fission process to make helium. 3 heliums make a carbon. Each carbon fuses with 2 heliums, make a neon. So the output is oxygen, nitrogen, and neon. Where did the oxygens come from? When I disassociate the CO2 and the H2O. I'm essentially recovering the oxygens that were part of the oxygens in the air that was coming into the carburetor. The carbons, we could fuse the carbon with a helium. It would make an oxygen. If that what was going on when I measured the presence of how much, or computed I should say, how much oxygen we would have like 30% oxygen. Someplace much higher than 20%. So that can't be because it doesn't fit the measurements. Neon. Well, if I take an exhaust analyzer made for automobiles and I put it in the exhaust pipe of a car or of a combustion engine of any kind, I'll measure the oxygen, I'll measure the nitrogen, I'll measure the carbon dioxide, I'll measure the CO2, I'll measure the nitrogen oxides. I will not measure the neon. So this hypothesis, which I have, is testable. You just get a general gas emissions kind of instrument that it picks up the presence of neon. If the presence of neon is there, then we have something that's consistent with the hypothesis. Is there's no neon there, we have to go back to the beginning and figure something out. There are multiple pathways. I just talked about one. What about the residue of the elements in the spheres? Where do they come from? So there's a process. This depicts the alpha ladder process. This is the process that happens in stars after they have burned, if you will, or fused all their hydrogen. Like our sun, it's producing energy by fusion of the hydrogens to make heliums. The heliums build up to the point that all of the elements, all of the atoms of hydrogen have been fused to helium, and all that's left with helium. And then the stars start a different process where they burn and fuse helium. And you go up the ladder. this way. This is the alpha ladder, and this is the what Malcolm calls the omega side, the odd numbers one. And each of these fusion processes, when you do the fusion, you are increasing the energy. You generate additional energy as heat, for example, as light, for example. And this is what comes out from the stars. So this is interesting because this explains what is going on with the residues, what is going on with the residues of the... Now, if we want to look closer at the different reactions, this is the reactions involving hydrogen. A hydrogen within a hydrogen fuse together, then it creates an isotope of hydrogen, which is called deuterium. And you can see it emits energy. For each time that happens, 1.442 million electron volts are released. The deuterium fuses with a hydrogen to make a light helium, a helium who has atomic number 2 but atomic weight 3. That helium fuses with a like helium to make ordinary helium, which has atomic weight of 4 and atomic number of 2, and it releases 2 hydrogens. So what happens, we had a process that's actually used 6 hydrogens, comes to the last place, makes the helium and releases 2. So it takes 4 hydrogens in this process to make the helium. And this is the reactions which are going on in the red giant stars. What about carbon? We have 2 kinds of reactions with carbon. There are many others, but I'm listing 2, the ones that are consistent with the hypothesis. Carbon, which has a weight of 12 and an atomic number of 6, is fissioned, and it makes 3 heliums of atomic number 4, atomic number 2, atomic weight 4. And this process is an endothermic process. It requires energy. The other process, where I'm taking a carbon and fusing it with 2 heliums to make the neon, is an exothermic process and releases energy. Notice the release of the energy more than compensates of what the energy that has to be absorbed for the fission process. We can have some oxygen helium fusion. 2 oxygen with 1 helium will get us to an argon, and it releases energy. So if this is one of the things that happen, we're expecting in the exhaust argon to a higher percentage than around the 1%. It's just a little less than 1% in there. That's another test that can be done. And we're coming to the end here. The instruments that we need: mass spectrometer, emission gas analyzer, not the exhaust gases analyzer, it's something more general, and a scanning electron microscope with a dispersive energy spectrometer, which gave us the concentrations. We expect to see in trace gases some hydrogens coming from the dissociation of water that have not fully fused to get to the helium stage. Heliums which have not fully fused onto the carbon. Argon, if we're actually fusing oxygen and helium together, they'll be a little greater than argon. Carbon dioxide we expect to be very small. Carbon monoxide below 1%. Nitrogen oxides below 1%. And the major gases: nitrogen, oxygen, and neon. Neon is a noble gas. It doesn't interact with anything. Never been measured by exhaust analyzers. Of course it's not measured. Who would think that a combustion engine, connected in whatever way, is something which has no electricity, just pipes, is going to make new elements and even a new gas. So this is completely testable. If the test results that we measure some neon, and we measure some argon, and we measure some helium and hydrogen, it's telling us the process we are talked about. This information would be consistent with it. But it doesn't prove that the hypothesis is true. It only says, so far we're consistent with more measurements. In science, actually, you never prove anything. Everything is a hypothesis, even that which is lost, so-called lost. All we need is one kind of observation which is not consistent with whatever we think the laws are. Science changes. That's what moves science forward. So, this is testable. We're going to be acquiring all of these instruments here, plus others. We will actually do the testing. And finally, if you're interested in the slide set, email me. The email is like my name, robert@haralick.org. And I will give you the Dropbox URL to pick up the PDF file of the slide set. Thank you, everybody, for listening.
All right, remember this is just the first part in our Alpha and Omega ladder series of interviews, lectures, and announcements that's going to be coming up during the next few weeks. So pay attention. There will be a few more videos to come. Next up, we also have, again, a follow-up interview with Robert, where we elucidate some of these ideas, talk about the things around it, and some of his personal experiences with the Thunderstorm generator, with Malcolm, some of the developments happening in the US on the commercial and industrial and scientific side. So that's going to be really great. We also will have a lecture and an interview from the wonderful Sheila Rahman, the frequency scientist, who's a fellow student of Malcolm Bendall, who has also been elucidating on this science. And she has some of her own ideas to add in here. And this is a really fantastic lecture. We're going to be interviewing and following up with her as well. Keep an eye out for that. Next, we also have an interview with Combe Carpenter, who is a distinguished fellow of the India Foundation, a writer, an author, public speaker who's been involved with the Thunderstorm generator project for several years now, and he elucidates on, well, plenty of interesting topics, including, some of the historical Vedic spiritual side of things, as well as some of the practical updates going on in India and the implications for the world. So that's a really great interview as well. We may hear from Malcolm Bendall himself, and there is also some huge announcements coming up from all of those involved partners in the project. So I look forward to covering all of this. It's incredibly exciting to see all of this coming real on all levels, and at this stage, I can say we've made an impact on the world here. Congratulations, Malcolm. And I'm really proud to have supported this and been involved in its early stages. I'm so excited to see where all of this is going. And thank you for all being involved as well and following on, keeping this in the public, and all the support and the connections that have been made through that has really been absolutely integral to all of this happening.